Hello, students. Welcome to our Math 10 class again. But before that, we'll have our devotional first. The message is entitled The Focused Life. Our memory text is found in Philippians 3 and 14. Brethren, I count not myself to have apprehended, but this one thing I do, forgetting those things which are behind, and reaching forth unto those things which are before. I press toward the mark for the prize of the high calling of God in Christ Jesus. Many people accomplish little because they scatter their efforts. Instead of focusing on one great objective, they waste their strength dabbling this and that. When they come to the end of life's road, they leave no monument behind, only a tombstone. How different was the life of the Apostle Paul. This one thing I do, he declared. He had but one great ambition. He was determined to preach Christ everywhere, develop a character like his Lord's, and at last, hear the masters say, "Well done," how fully he succeeded. In modern times, the power of a focused life is well illustrated by the experience of Charles E. Stillings, a railroad worker. Mr. Stillings had one overpowering purpose to leave a scholarship fund as a memorial to his father. His first job paid $5.6 a week. Later, as foreman of the power plant of the New Haven Railroad at Cost Cobb near Stamford, Connecticut, his weekly earnings rose but never reached $100 a week. This was hardly the kind of income on which most people would attempt to establish a scholarship fund. But Bachelor Stillings worked on, lived simply in a shabby hotel room, laid aside a recent not absolutely needed, and invested his savings. When he was 81, Charles Stillings established the scholarship fund. The University of New Hampshire announced that it had received $228,000 from Stillings, the largest gift ever received from a New Hampshire University alumnus. At the same time, news leaked out that the retired railroad worker was worth $500,000, virtually all of which was earmarked for the university. Like Paul, Charles Stillings had declared, "This one thing I do," and he reached his life's objective. What is your aim? To be like Jesus? So, this moment, we will be talking about geometric sequence. Now, what is a geometric sequence? A geometric sequence is a sequence where each term after the first is obtained by multiplying the preceding term by a non-zero constant called the common ratio. The common ratio R can be determined by dividing any term in the sequence by the term that precedes it. Okay, consider this sequence. We have 32, 16, 8, 4, 2, 1, and this is called a geometric sequence. Now my question is, what is the common ratio for this? Okay, thus, the geometric sequence 32, 16, 8, 4, 2, the common ratio is 1/2, since 16 divided by 32 is equal to 1/2, or shall we say 0.5. So we have the formula for the nth term of a geometric sequence. So we have a sub n is equal to a sub n minus 1 times r, or a sub n is equal to a sub 1 times r to the power of n minus 1. So that's the formula for the nth term of a geometric sequence, where A sub n there is the term that you are looking. The a sub 1 is the first term, and the r is the common ratio, and the n there is the total terms, or how many terms, Example, what is the 10th term of the geometric sequence 8, 4, 2, 1, and so on? So there are only 4 given, and you are going to find the 10th term. Since r equals 1/2, because 4 divided by 8 is 1/2, then a sub 10, because we're going to get the 10th term, equals 8, which is the first term, times r, which is 1/2 to the power of 9, equals 8 times 1 over 512. It becomes 1 over 512 because 1 times 1, or 1 to the power of 9, or there are 9 ones that you are going to multiply, the result is still 1, and 2 to the power of 9, or you are going to multiply 2 9 times. So the result is 512. So 8 times 1 over 512 is 8 over 512. And we have to reduce that to lowest term. So 8 divided by 8 and 512 divided by 8 is 164. So their GCF, or the greatest common factor that is divided at the numerator and denominator, is 8. Okay, next. Find the first term of a geometric sequence which a fourth term is negative 40 and which common ratio is negative 2. So in this example, we're going to find the first term, and the given is the fourth term and the common ratio. So what shall we do with this? Substitute a sub 4 equals negative 40 because the fourth term is negative 40, and n equals 4 because there are 4 terms since negative 40 is the fourth. So in the formula, a sub n equals a sub 1 times r to the power of n minus 1. We have to substitute the following given. We substitute negative 40 to a sub n is equal to a sub 1 because we don't know what is the first term, and that's the one we're looking for, times negative 2 because the common ratio there is negative 2 to the power of 4 minus 1 because our n is 4 because there are 4 terms. So we have negative 40 equals a sub 1 times negative 2 cubed because 4 minus 1 is 3. So negative 40 is equal to negative 8 because negative 2 cubed, or negative 2 times negative 2 times negative 2 is negative 8. Just take note that if we are going to simplify an exponential expression that the base is negative and the exponent is an odd number, the result is always negative. So we have negative 40 equals negative 8 times a sub 1. Since we're looking for the first term, or the a sub 1, and the numerical coefficient is negative 8, so we will apply the division property of equality. We need to divide negative 8 both sides. So negative 40 times negative 8 is positive 5 because negative divided by negative is positive. And we have negative 8 times a sub 1 divided by negative 8 is a sub 1. So our first term, or the a sub 1, is 5. Okay, we will go to geometric series. What is that? Geometric series. So here in this situation, many schools set up a cell phone brigade to notify students when classes are suspended due to typhoons, flooding, or other weather disturbances. Suppose a school sets up a cell phone tree so that each student, except those in the last level of the tree, calls 3 students. So we have here the first 5 terms of the sequence for the number of students at each level of the tree are blank, 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 blank. So what are these 5 terms? So we have 1, 3, 9, 27, and 81. And what is the common ratio for this? That is 3 because 3 divided by 1 is 3, 9 divided by 3 is 3, 27 divided by 9 is 3, and 81 divided by 27 is 3. So the common ratio for this is 3. Okay, the sequence is geometric with a common ratio 3. Okay, we will go to this example. To get the number of students informed up to the 7th level, we use the formula. A sub n is equal to a sub 1 times r to the power of n minus 1. So, as we know that the first term is 1 and our common ratio is 3. And we're going to solve the 6th term or level. So, we have 1 times 3 to the power of 5 because 6 minus 1 is 5 and that is 243. And if we are going to get the 7th level, we have 1 times 3 to the power of 6 because 7 minus 1 is 6 and that is 729. So to get the geometric series, we're going to get the sum. So a sub 1 plus a sub 2 up to a sub 7. So we will add 1 plus 3 plus 9 plus 27 plus 81 plus 243 plus 729 is 1093. So that's the geometric series. We're going to get the sum of geometric sequence that is called a geometric series. So we have also the sum of the first n terms of a geometric sequence. The sum of the finite geometric sequence is calculated by the formula. S sub n is equal to a sub 1, which is the first term, 1 minus r to the power of n. 1 is constant there. The r is the common ratio and the n is the number of terms. All over or divided by 1 minus r. 1 is constant there and r is the common ratio. So you have to remember where a sub 1 is the first term, r is the common ratio, and n is the number of n terms. Example, find the sum of the first 12 terms of the geometric sequence 3, negative 9, 27, negative 81, 243, and so on. So there are only 5 terms given and you are going to get the sum of the first 12 terms. So what shall we do? We will get the given of the geometric sequence. So as we know that the first term or the a sub 1 is 3 and our r, the common ratio is negative 9 divided by 3 is negative 3. And we'll solve for s sub 12 by substituting n with 12, a sub 1 with 3 and r with negative 3 into the formula. So we have s sub n equals a sub 1 times 1 minus r to the power of n all over 1 minus r. So we will substitute s sub 12 equals 3 because our a sub 1 is 3 times 1 minus our common ratio is negative 3 and our n is 12. So all over 1 minus negative 3. So s sub 12 is equal to 3 times 1 minus negative 3 to the power of 12. We have 531,441 divided by 1 plus 3 because 1 minus negative 3 is the same with 1 plus 3. And we will simplify. S sub 12 is equal to 3 times 1 minus 531,441 is negative 531,440 divided by 4 because 1 plus 3 is 4. So if we will multiply 3 times negative 531,440, the result divided by 4 is negative 398,580. So that's the sum of the first 12 terms. Given 3, negative 9, 27, negative 81, and positive 243. Okay, we will go to geometric means. The terms between two given terms in a geometric sequence are called geometric means. Example, insert 2 geometric means between 7 and 875. So there are 4 terms in the given sequence. The first term is 7, and we are going to insert 2 geometric means, and the fourth term is 875. So first find R, or the common ratio, using the formula, because we don't know their common ratio because the second and the third term are missing. So we have A sub 4, because there are 4 terms, equals A sub 1 times R to the power of 4 minus 1, because our N here is 4. We know that the fourth term is 875. Our first term is 7, and we don't know the common ratio. So we have 7R cubed, because 4 minus 1 is 3. Since we will look for the value of R, or the common ratio, so we will divide 7 both sides. That's division property of equality. Since 7 is together with R cubed, so we will divide 7 both sides. 875 divided by 7 is 125. And 7R cubed divided by 7 is R cubed. Now, our aim is to get the R. So we still have R cubed. So we need to extract the cube root both sides. So the cube root of R cubed is R, and the cube root of 125 is 5. Because 5 cubed is 125, or 5 times 5 times 5 is equivalent to 125. So the cube root of 125 is 5. To complete the sequence, multiply 7 by 5. So we will multiply 7 by 5, because the first term is 7. 7 times 5 is 35. 35 times 5 is 175, and 175 times 5 is 875. Therefore, the required geometric means are 35 and 175. So in integration of faith and learning, like the sum of geometric sequence, God has already arranged the sequence of our lives, so we have to trust Him and follow His will always. Just remember the promise of God in Proverbs 3, 5, and 6. Trust in the Lord with all your heart and lean not on your own understanding. In all thy ways submit to Him, and He will make your path straight. So that's all for this moment. I hope you learned something about geometric sequences, geometric series, and geometric means. God bless everyone.